Hi, everyone. Thanks for tuning in to the Printed Circuit Podcast, where we will discuss trends, challenges, and opportunities across the printed circuit industry. I'm your host, Steph Chavez. In this episode, we'll focus on design and manufacturing collaboration. And here to join me in this discussion is Jerry Partita, Vice President of Technology and Summit, Interconnect. Thanks for being here, Jerry.
Thank you, Stefan. It's a real pleasure to be here with your podcast, and I look forward to more podcasts in the future.
Definitely. Jerry, before we get started, I always like to let people know my guests, their background and their expertise they bring to the table, because you sure do bring a lot to the table of what you do. So can you give us a brief introduction of yourself?
I've been in the industry for 38 years. I started off at Everett Charles Test Equipment, building test fixtures. And we got repair stations, which introduced me to Gerber Data. And at that time, Optratec, which becomes Orbotech, was looking for somebody with experience. And I got in when CAM just gets started in our industry in 1986. I was at the right place at the right time with the right company. From there, I gained quite a bit of experience, probably visited almost 100 board shops in the time I was with Optratec, Orbotech. And later on, about 27 years ago, I went to work for the PCB fabricator and have been building boards in the last 27 years. And I got involved with IPC about 2005 heavily, joined committees probably the next year, and have been a part of different standards, developing new standards, as well as working on old ones. And currently I'm vice chair of IPC 6012 and the Weak Microwave Reliability Study Group. So that's kind of been all the things I've done in my career over this time.
That's outstanding. I mean, like I said, you sure do bring a lot to the table. You're a dear friend of mine, and I really love Summit, what you guys do there and the quality you guys bring to the table for the industry of all the clients that take advantage of your guys' services of what you guys do. So it's truly amazing. You and I collaborated on integration or a dialogue back in October of 2022. We got together at one of the PCA chapter meetings hosted by Scott McCurdy, and you and I, just kind of winged it, and we put together like a little comedy routine that really took off. We didn't even think we were afraid how it was going to go, and you and I killed it. First of all, if you get you and me together and we start talking, it's like nonstop. You can't stop us because we both have a lot of passion. But in that discussion and continuing forward, which you'll see us again at PCB East, that is in May this year, if anybody's tuning in that will be attending that conference, please come check us out. But Jerry, tell me, and tell you honest, what doesn't work today when it comes to the design and manufacturing collaboration?
I think the thing that doesn't work or is a challenge to make work is that we design things, ask for compliances to the IPC standards. Sometimes they're not a match, where the components might be very dense, the density of packaging of components on a circuit board, and not following design rules. But then asking for at the end that the board be compliant. We run into these problems where they didn't check to see if they were designing to compliance, but they asked for it anyway because they have their customers that have to satisfy that they met certain standards, and also checking the work. People change data, update, revise things, and forget to update drill charts, or they took an impedance line out of an impedance table and it doesn't exist in the design. We're like, is this the wrong layer? Is this the wrong size? So just double checking the work. I mean, how many of us write emails and don't reread what we just wrote before we hit send? We just write and send, and somebody says, what did you mean by this? And they're like, oh, I didn't mean that. I meant the opposite of that. That's kind of the challenge today. We build product that has to maintain reliability and has to be compliant to all the documentation. You can't just redline prints for military customers. They have to be completely legit and traceable. But in our factories, especially our military customers, about 70% of the jobs are on hold because the documentation's wrong or what is asked of us to build has not been designed in. And this is just every day for us. And I always joke that the front-end engineering department at board shops are an impediment to manufacturing. People go, what do you mean by that? I go, we can't build anything until we cleared all the questions and we understand everything in there. And 70% of the time, things are on hold. And so we lose time for manufacturing as we're trying to resolve those questions. We usually get it back from the customer, but the customer says, why did it take so long? It's like, well, same questions you had the last 5 or 6 or 10 or 20 part numbers. You just haven't put in rules to avoid these questions or these delays. So that's kind of what doesn't work.
As you were speaking, like all these flashbacks that, in my past, things that I've seen of, first of all, I hate technical queries. As a designer, I hate it because to me, that's a work stoppage. And like you said, there's a good chance, almost like 95% of the time, You could have prevented that yourself if you just read your FAD document for the data that you produced and then for what you delivered and what you're asking for. I can attest to that. Believe me, I've seen my share on design teams that I've been on or that teams that I've participated with regarding like just giving some advice. When I see, the technical query come back and it's like, okay, you're asking for class 3, but your annular ring or your aspect ratio, it's not. Or your impedance requirements, did you even work with the fabricator from the beginning? And when you design your board, you didn't do that. So now you're asking for magic and you're hoping the fabricator can pull it out and do some magic wand and wave jazz hands to it or whatever and make it work. Or like you said, one of the most simplest thing is you're asking for a 100 ohm differential, let's say on layer 5, but there's no 100 ohm differential traces on that layer and on your document, your FAD document. So yeah, I definitely I've seen it and I can attest to it. And that's why that skip routine, we did it. Oh my God, it's hilarious the way we were working that. So
for the folks playing at home, that the skit, what we did is we went over the classic questions that occur between a design and a fabricator and trying to resolve it. And it's just like, well, can't you just do that? And I'm like, no, I don't know what, we have to be certain what we're doing. Like I said, 70% of the stuff's on hold. There's plenty of topics to share in the skit. We actually whittled out probably half of the different items we could have these skits about. And the skits, each scenario was just simply a training moment, a teaching moment, and just having fun with it of what goes on in the minds of the designer and the fabricator.
What's really scary though, Jerry, is that those are real problems. Those 20 things that we chose are real that you see today. And that's what's scary. It's continuous. And it's not just from one customer or one company. It's across the board that you see this kind of interaction or lack of it. And then they're asking for the fabricator to please save me and bail me out. And I know, in the mil-aero industry, it's very expensive to make a change on a drawing. I mean, you could be anywhere between, I say $4,000 to $6,000 to maybe $15,000.
I hear that's usually $20,000 because there's a typo on a dimension. It has to go through the whole process and it has to go to their customer for approval too.
Mm-hmm. It's a ripple effect. And like I said, I hate technical queries and I do my best to prevent them. So, when we talk about preventative, so we know what the problem is. What can we do, or what is the solution or the best practice that PCB designers should implement?
So it's something that I've thought about over the last 3 or 4 years. I really believe the designers should have read through IPC 2221, IPC 2222 for rigid boards, 2223 for rigid flex and flex designs, and a new one, 2228. You don't have to memorize it. Just read through it and know there's certain rules about pad sizes, drill, minimum spacing, keeping features away from the edge of the board, different things that have to be considered when you design the board, and make rules on, like, if you're specifying minimum dielectric, copper weight, how much current you carry, what's the minimum copper in layers, and also to read the performance specs. We fabricators read the designer's design specs, 2221, 2222, 2223. We read them to understand these, to give them how they should have applied the rule. So the performance specs, or what is evaluated on the finished board, is IPC 6011, 6012, 6013, and 6018. I highly recommend that they just read those and understand their boards at the end have to meet these rules. So you have to design them in so that we can meet these rules.
Absolutely.
And I think if many of them read through it, they would be so much better off, because I get calls all the time. It's like, what's the minimum pad size I should use? I go, there's actually a rule. It's actually a pretty straightforward rule. People think it's an old rule, but I go, no, the rule actually works. It actually pushes us a little bit to the limits, but it's a practical rule. And if a board shop understands how well they can maintain registration during the different sequences, if they just would read the rules in place and try to apply them, you'll have a better outcome. I'll give you an example. We had a board that was getting 25% yield, 5 lamp cycles, 2 blind on top, 2 blind on the bottom, brought together. They didn't follow certain design rules, and we were getting 25% yield. And the end customer, which was a military product, was like, well, what can we do about this? Like, well, they didn't follow the design rules, but well, can you help with the design rules? We said, yes, we can. So we went back and redesigned the board, and it had like 7,000 locations where they drilled the copper because they removed the non-functional pads and routed traces too close to the drill, which you're not supposed to do. And it's in the design guidelines that says don't do that. And We didn't move any components. We left all the components where they were. They added like a capacitor here or a couple components there, but all the components, all the connectors, we left them alone and designed them the way they, per the rules, the design guideline rules. And so the guy calls me back, hey, I know we had 7,000, 6,000 bad locations. He goes, I'm down to 34. I can't fix it. I go, fine, 34. That's a lot less risk from 7,000 to 34. I can accept that risk. And when we built those boards, we got 88% yield. Now, they didn't move any components. It's the same design, the same connections. For the most part, they just simply followed the IPC rules. And we went from 25% yield to 88% yield. So following the rules can be impactful. And all we did is we applied the rules. We just looked at it and said the design doesn't meet this design guide rule and this one. Let's change this. Let's do that. Work it in. And it took them about a month or two to redesign it. And we tripled the yield.
Wow. That's amazing. I would tell you, when it comes to the IBC specs, I mean, they're there for a reason. These are industry experts and people with a lot of passion that volunteer their time to bring the best to the table for these specs. And they've been around for decades, several decades. And these are the best practices. This is what's guide you to make sure you can be successful in producing your board or your design. And it amazes me how many times I hear engineers make a comment, well, that's not a hard law. That's just more of a guideline. And I'm like, are you kidding me? There's engineers that have been doing this for 50 years, put their heart and soul in this, in these rules.
Yeah, there are some that have been doing it for 50 years.
Yeah, and it's not just from one company. It's talk about all the top Mil-Aeros and all the other commercial companies that really dig into that. So it just amazes me. And, when I think about the best practices is bi-directional communication. I mean, the fabricator is a stakeholder that's got to be brought to the table from the very beginning. And I think whether your design is a very simple design or complex, we need to be talking to you from the very get-go. That way, we plan our strategy, implement it as best we can to mitigate all the risks.
If you've read through the design guidelines and the performance specs, and you think you're pushing beyond the rules, that's the time to call us and say, listen, I have this design and I want to do this. I'll give you a simple one, which is easy to manage. I need a dielectric that's less than 3.5. The rule says, if not specified, the minimum dielectric is 3.5. Can you do less than 3.5? Sure. Yeah, we can. What do you need to do? And it's like, oh, I need a power and ground player. You can use a 1 mil buried capacitance core, and you can get it all the way down. I can. Yes, you can. It's possible to do it. Or like they'll do internal blind or buried vias, and they stop on a signal layer. Can you stop on a plane layer? Why? Because if you stop on an impedance layer with signals, it's going to get plated internally and act differently than your other print and etch internal signal layers. If you want them to act all the same, you might want to stop on a plane layer, which I'll get better yields. You'll get better consistent performance. And they go, oh, well, I could just move the blind via or buried via to a different layer. That's fine. Everybody wins. So having those conversations can make the difference in yields. There was one design, really complex, 6 microvias deep. And they were originally going to stack them all the way through. And I said, don't do that. They're going to fail. So there was 2 double buried blinds that came to the microvia stacking all the way out. And we went through the design 4 times. And we did, there was plane layers where they dog boned the microvias and they did impedance. So they had a pad that's like 12, a trace that's 20 mils long that was 3 mils because the impedance, and then a 20 mil pad. I go, you really don't have impedance. The pads are bigger than the line. The diameters combined are longer than the length of the trace. Just make it an 8 mil trace. I go, you're not going to get impedance, but I'll get better yields. There's no chance of me etching it out. And we had the double E on the call. He goes, you're absolutely right. Just change it to 8. And so we built this. There was 3 part numbers, these really gnarly boards. And we built 3 different part numbers in 4 weeks on time and 4 week schedule. Everything that we could make practical, we made practical. Where it had to be difficult, it was difficult, but we knew those layers. We just took out a lot of the risk on the more riskier layers, and you built something that had that many lamination cycles and nailed it in 4 weeks, three different part numbers. Collaboration usually leads to really good success.
So tell me, what do you see that are roadblocks that we can remove to implement best practices? In other words, we know roadblocks are there. So what can designers do or design teams do to help remove these roadblocks?
You have to be open to the design might not be right, and then you have to start over on certain parts of it. And so I think we do in our skit, the DFM. Oh, you want me for free to go through your design, which you didn't bother to check. You want me to list everything that's wrong. And then you're going to argue with me on everything you asked me to find for design for manufacturability and ask me if I can just build it the way it is. Although you asked me to give you all the information. So when you get that feedback, look at the opportunity to incorporate the recommendations. If not, it'll impact yield. There was I forgot where it was at, some symposium. They talked about from design to receiving your circuit boards, in between is Death Valley. And so if you set somebody up with bad provisions and ask them to get across Death Valley, they may not survive and get there. But if you provisions, good attributes, good design rules, with good chance of success, you can get from point A to the other side of Death Valley successfully. If not, you're just going to die all the way across because you didn't carry enough water, your equipment broke down, you don't have enough food, there's bad weather, bad circumstances, and you died in Death Valley. So I was like, oh man, that really describes it to a T. I'll give you an example. Last week I had a DFM and I pointed something. They go, hey, why didn't you point this out in the DFM? Because now it was an order. And I'm like, so everybody goes, hey, you didn't point this out to the customer? I go, pretty sure I did. And then when I looked at what I had sent 2 months before, I'm like, no, I said the same exact thing. They simply didn't do anything about it. And now that we're building it, and it's like, make a ruling. Do you want it to be a 1 mil annular ring, or do you want tangency? Because you didn't design tangency. It's one of those things. It's like, it's a funny thing about DFMs. If we miss anything and we actually get the order, they get very mad that the thing we did for free, that we missed something.
I laugh because I think of all the little things that are missed and then it's tossed over the fence, so to speak, and then they want you to produce gold.
And the thing is that at that point, when it's thrown over the fence to us, there's 2 budgets that have been burned. There's the money budget to design it, and there's the time budget to design it. And to have somebody go back, you know what, you're going to have to, if you want one class 3 annular ring, you're going to have to go change all your traces and reroute them. And it's like, we don't have time or the money. Then it's not class 3.
Exactly. Or you have on a drawing where somebody made a last edit and they moved some vias or eliminated vias, and then they forgot to rerun the drill. So your drill chart doesn't match the amount of vias that are truly in the board, and your drill count is off.
Well, this is one of our favorite ones. Hey, we need to change something on layer 2. We're just moving traces. That's all we're doing. And then they send new data and go, you have another drill. Your drill count changed. That means everything is no good. Everything has to start over. That's another one of my pet peeves is like, sometimes designs have an error is found after we've received the first revision of it. And when there's a slight modification to a silk screen or solder mask or something, they fix the original error that was missed. And all of a sudden, this is not the same design that we originally got. So,
we talked about roadblocks within the company, or roadblocks that we would see that I asked, what do you think people can do to prevent the mitigating the roadblocks? And you describe that. And when you think about internally within an organization themselves, what do you see that someone can overcome or a design team can overcome from your perspective, even though you're on the outside of the organization? How do you think, especially, when it comes to delivering data to you from intelligent data, whether it's, ODB++ or IPC 2581, or just, raw data, whether it's Gerber data? I say raw, but, dumb data like Gerber data. What is your perspective?
When data is supplied to us, as long as it's clean, we can translate Gerber data just, takes like sometimes 20, 30 minutes. A more intelligent database like ODB plus TGZ or 2581, if people will supply that, we can read it in. We have all the intelligence, all the layer sequences done, plated versus non-plated holes are set. We can look and analyze the data in a minute, where if you have Gerber and ASCII drill files, it can take 30 minutes before you set it up, before you can actually start analyzing it. But that's not what holds us up to tooling or doing a job. The problem is there's problems in the data. There's problems in the procurement documentation that you got to drill down through all of that to see what is it we're trying to build, or what is it that is allowed. Right now, I have a number of part numbers that I have to read a drawing that has a 40-page document that calls out another 30-page document. And I got to see who supersedes who in the design of the product. Just to get set up to go through, read, and get ready, it takes about 30 minutes just to get all the documents in my head, and then start looking at what is the rule that's applied and can it be built or is there a problem? And then if it is, then I have to document why this is a challenge or in the design for manufacturability, and they can be impactful. So the roadblocks are probably overcomplicated. I call it over tolerancing. This tolerance goes to that tolerance to this tolerance. I go, wait, you can't point all these different tolerances together. Just think it through. I think people sometimes get, and this is kind of in the weeds, GD&T. They'll call out GD&T requirements and not sure whether it can be met or not. They just take it off a component design guideline and they just globally throw it across the entire board. And it's like, no, that GD&T was only for that one connector, not globally, because it can't be built. And then people say, well, the other, this happens once in a while. Your competitors don't complain about it. I go, are you checking the GD&T? I go, because I guarantee you couldn't make this work. And they go, well, no, we're not checking. So then how do you know? I'm telling you, you've asked us, we're going to verify it. I can't even make it happen. So like a true position of 3 across the board that's 12 inches is like, this is never, you can measure it, be in tolerance, take it out, put it back in and be out of tolerance on this, measuring the same part again. It's that small of a feature. Understanding what you're asking for and whether it can actually be built in a design. So that sometimes will happen. Probably one of the roadblocks, and I don't know any way around it, especially with our military customers, we can't talk to the designers. We have to talk to buyers because everything's controlled by PO. It is a legal document between companies, and we can't talk to the designers. And if this is a CM that's building it for a military prime, that makes it even more of a challenge because we have to explain to them. They don't design it. They may not be aware of what fabricator terminology or designer terminology is, and we're trying to articulate information to them so they can send it to their customer and then resolve the problem.
One of my pillars of the best practice that I've been discussing, since PCB West last year, and then as part of a campaign this year of industry best practices, from Siemens, of what we're bringing to the table and showcasing is just that, making sure that when you're collaborating with your fabricator, that you're doing it from the very beginning. When it comes to the data that you're producing or the data that you're sharing with one another, and that you eliminate and mitigate all risks that are potentially could be there so that it's a team effort. It's really scary what's going on today, or what continues to go on today, where what you are seeing in firsthand. And we make a joke of it during our comedy routine, but that's in reality, it's not funny. I mean, you're talking about a lot of money, a lot of time, and a lot of redos that are unnecessary.
There were a lot of redos in the past. I remember seeing a certain OEM at the end having many, many rev rolls, and the board shop loved it because they got paid every time they built a rev. This was my Optratech days. It's also the evolution, right? The guys that laid out design were graphic artists. They laid out by hand lines and pads, and they had the Bishop Graphics little stencil book, and they put like color form and designed it. And then when they came to CAD systems, they took those people that did things by hand that were literally schooled. They went to school as graphic artists, and then they made them PCB designers. And then we did that for about 30 years. And now they're retiring. They've earned their retirement. And now we're going to design tools, EDA software tools, that this is for the double E. The double E can do his own design. And it's like, there's a lot of experience of what works and doesn't work that you need to make sure you have the rules in the EDA system. Otherwise, you'll make stuff that's not compliant. And so that's kind of today's new challenge, right? We've gone from the opposite. We went from graphic arts people that became PCB designers that use CAD tools to design PCBs. Now we're taking double E's that never applied the rules. They're great at designing electronics, but now they've got to design a PCB, and it's not a cakewalk. And some of the EDA guys will have, look how cool our software can do all this stuff. And it's like, yeah, but you can't build that.
As part of PCA, the Association for Printed Circuit Engineering Association, educational content is huge. And you've got to understand, when it comes to designing boards, you've got to understand the basics of printed circuit board design. And if you don't understand that and you can't apply it, I don't care how powerful your tool is or how much you can wield that tool. If you don't understand the basic concepts, you're dead in the water. You're going to produce garbage, and they're going to toss it over the fence to you and ask you to produce gold for them. And you, the fabricator, it's not going to work. or it's going to be very, very costly in order to get it to work. Don't get me wrong. There's a lot of good content out there, and there's a lot of great teams and great people producing some really good stuff. But at the same time, there's people producing, or you go to YouTube, you can see so much stuff, but you got to be careful. And in the end, as I think about what is the best practice, the best practice is to contact your fabricator from the get-go and work with them from constantly throughout your process to make sure that what you want built or what you asking to get built is designed correctly. So you design quality and you design it correct by construction. You don't check for it at the end and then hope you're closing your eyes and throwing with a blindfold on trying to hit a target. That's definitely not the way to go. Jerry, it's been a great discussion. To the folks out there, there you have it. When it comes to the discussion between design and manufacturing collaboration, it doesn't get any better than this, what Jerry and I discussed. Jerry, thanks again for your invaluable insight, what you shared with us today. It's truly an exciting time to be a part of the industry. And to all our listeners out there, I want to make sure you continue to tune in and follow along on the Printed Circuit podcast. Jerry, again, thanks for being on the podcast today, and keep it up, keep killing it, and Summit as well.
I'm looking forward to doing our podcast again. And I must say that our executive management from Shane and Sean are firm believers in supporting IPC and PCEA and helping to educate our industry from our perspective so we can be successful with our customers and they can be successful with the products we produce for them. So we thank you for allowing us to share.
Again, Siemens provides all the tools necessary to be successful, but in the end, it's up to the individual to apply, all the industry best practices that's out there and use it to their advantage. So thanks again, everyone.